Hello, in this video I will show you how to create easy-to-use footstep system with Niagara Data Channels for particle optimization and easy way to add new effects and sounds. So first, go to Project Settings, search for Physical Surface and add name to surface type you need. You can add up to 62 custom surfaces types and pay attention that there is also a default surface type that we're gonna use later. Let's create master material and few instances to test our system. We also need to create a physical material for each of our surfaces. You can find it under Physics tab. Inside Physical Material object, select your surface type and save it. Now assign physical material to each material instance. You can also set up material color. Let's do some cleanup in our scene and apply our materials to meshes. I also prepared some simple effects and sounds. Let's create sound cue using our audio. If you select multiple audio objects, it will add a random node inside sound cue. For particles, we need to create NDC object. It will let us spawn particles into single system instead of spawning own system for each step. Inside NDC, let's select Gameplay Burst. It's new type added in 5.7 that allows us to override Niagara system within NDC. Here I'm selecting default Niagara system to spawn, and I'm adding channel variables. Those will be read by the particle system. I will create position and normal. Inside particle system, make sure that the loop behavior is set to infinite. Add complete if unused in system update. That will remove unused systems. And in emitter update, add spawn from data channel and select our NDC. It will create 3 new modules: init data channel to save NDC reference, spawn from NDC to spawn particle burst, and init particle from NDC. That one will save our position and normal to each spawned particle. What I like to do is to store NDC as a system value, so I can save it once for every emitter inside that Niagara system. Make sure to replace new system value in spawn and init modules. And we need to do same thing with every other surface particle system. Let's put our materials into own folder. And now we need to create blueprint anim notify. You need to find it in all class tab. This class will be triggered by animation. Next step is to create override for receive notify function. From mesh component, add get socket location and make parameter out of the name value. This parameter should be exposed. That will be our bone name to select. Then add 2 vector add operators, one with positive offset in z-axis and second one with negative z-value. Plug them into start and end pin of line trace by channel. For now we can also enable debug draw. Then you need to open your animations and add our notify. I will do it to all my run and walk forward animations. Add new notify track. Right click, add notify and select our notify blueprint. In details tab you can find exposed socket name value. can check bone names in Skeletal Mesh Editor. You need to add new notify for each moment that foot touched the ground. Now we can test if our notifies are working correctly. Let's add a branch node behind our line trace to do nothing if for some reason trace won't hit anything, and break our hit result. Now let's create data asset blueprint. It will contain a list of sound and particles for each physical material. We also need a structure that will have a reference to Niagara system and sound cue, and data asset object made out of our data asset blueprint class. Inside structure, add two values, sound cue and Niagara system. Then go to our data asset blueprint and add value of type physical material. Then change it to be a map, and as a second value, select our struct. In our data asset object, we can now add sounds and particles for selected surface types. Let's start with the default surface type. In our blueprint notify, add new variable of BP data asset type that we just created, compile it, and set it to our data object. Now let's get this value. We can convert it to validate get, so it won't do anything if the value didn't load. Get our surface map from it and use it with find function. Key is our physical map from hit result. Break the function. And now let's add write to Niagara Data Channel node. Select our NDC that will add our position and normal values that we want to pass. And create access context node out of access context pin. Hide all values and unhide only system to spawn, override system to spawn, and location. Connect location. Enable override system to spawn, so we can override default Niagara system from NDC, and plug our Niagara system from our structure. Add play sound at location node, and plug our sound cue and location to it. Let's disable our line trace debug and test the system. As you can see, every unsupported material we use default surface type. Last tip. With NTC, your simulation position may work not as intended. Instead of that, you can replace it with saved NDC position in init particle from NDC. And that's it. Thank you very much for watching my videos.